Just before we get started with today's video, I do want to say that it's brought to you by the Great Courses Plus, an on-demand video learning service. It's got lectures from top Ivy League professors as well as experts from other places like the Smithsonian or National Geographic. It's basically like a university education but at your own pace, and there's no tests or schedules, and it's very easy to access. You can do it on PC, tablet, phone, whatever you're using. They've also got audio streaming so you can listen and learn on the move. Get a free trial by going to thegreatcoursesplus.com/TopTenz. Alright, so you're no doubt used to sensationalist headlines, especially when it comes to bad science, but you might want to take a deep breath, because in today's video, we're going to get deep into some of these. Number 10. There's a zombie apocalypse waiting to happen. In 1986, British beef was found to be infected with BSE, that's bovine spongiform encephalopathy. This was after cattle were being fed cows and powdered sheep, and who could have ever thought that feeding cows would be a bad idea? Anyway, against expert advice, a government spokesperson claimed that it was still safe to eat, but within a few years it became rather clear that it wasn't. In the early 1990s, 20 Brits were diagnosed with a deadly human form of the disease known as variant Creutzfeldt-Jakob, or VCJD. Like Kuru, a type of CJD afflicting Papua New Guineans who eat each other's brains, VCJD effectively mutates or misfolds prion proteins, ultimately leading to death. The average incubation period, however, the time it takes for symptoms to manifest, could be more than 60 years. In other words, anyone who ate British beef, including in baby food and gelatin, around the time of the epidemic, could be infected without even knowing it. Further, in the US, most cows are killed years before they're old enough to show any symptoms, so they could also be infected. Only 20,000 of the 40 million killed every year are tested. A major VCJD outbreak could therefore be in a not-too-distant future. Symptoms of VCJD include aggressive personality changes, memory loss, and problems walking. It almost sounds like a zombie apocalypse waiting to happen, except that it's pretty hard to catch. It's certainly not airborne, and researchers don't think that it can be sexually transmitted. However, in the UK, there were 2 million mad cows chopped up and eaten by the public, and with no treatment forthcoming, the prognosis for all of them is ultimately death. Number 9. There won't be time to stop an impact event. On Halloween 2015, a massive, approximately 1,300-foot asteroid, 2015 TB145, which apparently looked like a skull, flew past the Earth at just 1.3 times the distance of the Moon. Even a slight deviation in its course could have been catastrophic. Assuming an entry speed of 17 kilometers a second and a density of 2,600 kilograms a square meter, it would have impacted the Earth with a force of 2,800 megatons. That's 56 times the force of the most powerful thermonuclear bomb ever detonated, the Tsar Bomber, which itself was roughly 1,570 times the combined force of the bombs dropped on Hiroshima and Nagasaki. There are a number of things we could potentially do if we see an asteroid coming. We could fire a nuke at it, for example, in an attempt to alter its course. Or we could try ramming it with a custom-built rocket. Astronomers have also suggested shepherding it off course with a bombardment of plasma from a spacecraft flying alongside it, or even simply painting it white to let photons from the sun do the job. But the trouble with all of these strategies is the time they would take to implement, and in many cases we don't even have the technology to do it. Even if we did have a strategy in place and the spacecraft to carry it out, we'd likely need just a year to get it off the ground. Relatively minor space missions, for instance, can take upwards of 4 years to launch. And yet, we didn't even know that the Halloween asteroid existed until 3 weeks before it passed us by. That wouldn't have been enough time to do anything about it safely. Sure, we've made astounding progress to be able to track an estimated 90% of asteroids capable of entering the world, but 60% of asteroids the size of 2015 TB145, capable of depopulating a continent, by the way, are said to remain unaccounted for. Number 8. Climate change will cause super-eruptions. The last time Yellowstone super-erupted was 640,000 years ago, when it spewed 1,000 cubic kilometers of lava, pumice, and ash into the air. One of Indonesia's supervolcanoes ejected almost 3 times that, 2,800 cubic kilometers, just 74,000 years ago. In 2012, researchers concluded that Yellowstone is unlikely to erupt so cataclysmically for at least another few centuries. The US Geological Survey puts the annual odds at 1 in 730,000, or 0.00 0.0014%, similar to the odds of us apocalyptically colliding with an asteroid. But they note that these odds are simply based on averaging the two intervals between the last 3 major eruptions, so they're not exactly reliable. As they point out, catastrophic geological events are neither regular nor predictable. And one factor we don't tend to account for is climate change. We know supervolcanic eruptions definitely have an impact on the climate, but it seems that it goes the other way around as well. Researchers have found that even minor global warming can significantly increase the likelihood of eruptions. Theoretically, this has to do with the melting of glaciers that otherwise keep magma from rising. And while this doesn't really apply to Yellowstone, it could have devastating consequences for lesser-known volcanoes like Mount Rainier in the Pacific Northwest. Mount Rainier, incidentally, has been described as one of the most dangerous volcanoes in the world because it sits in such a populous region. In any case, it's clear that geographical changes are taking place in Yellowstone hundreds or even thousands of years earlier than expected. By 2011, for example, the ground above the magma reservoir had swelled by 10 inches in just 7 years. We don't know when to expect the next super-eruption, but inevitably there is going to be one, perhaps sooner rather than later as temperatures continue to rise. And contrary to what you might have heard, there probably won't be much of a warning. Number 7. The sun could destroy us tomorrow. On September 1, 1859, astronomer Richard Carrington watched from his observatory as a cluster of unusual sunspots began to emanate a blinding white light. Before dawn the next day, skies worldwide, even in the tropics, came alive with pulsating auroras of purple, red, and green. Meanwhile, telegraph systems, the only electronics in widespread use, went haywire, generating sparks, giving operators electric shocks, and even setting paper on fire. In fact, the atmospheric electricity was so great that telegrams could be sent even with the systems disconnected. And what was happening? Well, Earth was in the grip of a geomagnetic storm, a mammoth cloud of charged particles and detached magnetic loops. The Carrington flare was unprecedented. Naturally, some mistook it for the end of the world. But what they'd actually witnessed was a massive solar flare, a magnetic explosion on the sun, followed by an ejection of coronal mass, that's plasma and magnetic fields. Nowadays, we record such events in space using X-rays and radio waves. And while there haven't been any of this magnitude since, astronomers think that we may be due another. They're more and more concerned about this than they are about asteroids or supervolcanoes, the latter being 90,000 times less likely to erupt. The damage caused by a solar superflare today would cost us trillions of dollars, says astrophysicist R.V. Loeb, and that's assuming we even survived it. Not only do we have orbiting spacecraft and astronauts to worry about, but we're also far more dependent on electricity than we've ever been. Everything from financial systems to nuclear reactor cooling controls could be affected. Nuclear weapons could too. On May 23, 1967, when a solar flare disabled the US early warning system in the Arctic, nuclear strike protocol against the Soviets was initiated. If it hadn't been for a last-minute explanation from NORAD, which had only just established the Solar Forecasting Center, nuclear-armed bombers would have taken off for Russia. Further, because of the magnetic interference, there would have been no way to recall them. A superflare could also be an extinction event in several other ways. It could damage the ozone layer, it could disrupt ecosystems, it could even mutate our DNA. Number 6. Strangelets could make Earth a strange star. A strangelet is a theoretical lump of what physicists call strange matter. Composed of equally balanced up-down and strange quarks, strangelets would be heavier and more stable than ordinary matter and therefore thermodynamically preferred. As a result, strange matter could transform ordinary matter within 1,000th of a millionth of a second. This means that they could replace our planet like that upon contact. Strangelets haven't been found yet, and some think they never will be. It was feared early on, for example, that particle colliders might release one of these, and obviously that's not happened. But that doesn't mean they don't exist out there somewhere. Researchers are currently looking for strange matter in space by trying to find ripples in space-time. Strangelets could theoretically form inside neutron stars, which, despite their tiny diameters, for example 12 miles, can have the same mass as our entire sun. This kind of pressure can certainly do strange things to matter, and neutron stars could potentially eject strangelets into space. Now, just before we jump into the top 5 today, I do want to take a quick minute to tell you about the Great Courses Plus, because, well, if you're enjoying this very science-based video, you're going to love the content that they have on their platform. You can learn from the world's greatest science teachers on there, and if you're enjoying this video, then I think you'd really get a kick out of a video called Space, Technology and Discovery by National Geographic. There's also other great courses on stars, gravity, space exploration. There's tons of stuff that you'll probably like if you're liking this thing. But if you're looking for one to get started with, definitely check out that Space Technology and Discovery course. I personally really enjoyed that one, and I think you'll probably like it too. And I mean, it's not just space, it's not just science, they've got serious range. I just tried to choose something as random and unrelated as possible. They've got a course on chess, so you can definitely check that out if you want to. Whatever you're into, the Great Courses Plus, they've got you covered with top-notch stuff taught by some of the best educators in the world. Basically, it's a university education at your own pace. There's no tests, there's no schedules. You can do it on your PC, tablet, phone, whatever you want. And they've also got audio streaming so that you can listen and learn on the move, and there are 11,000 lectures to choose from. So yeah, great stuff, and you can try it for free. Get your free trial at thegreatcoursesplus.com/TopTenz, or just click the link in the description below. Doing that helps support the show. And let's get into those top 5, shall we? Number 5, either we're alone or the end is nigh. The so-called Great Filter is one answer to Enrico Fermi's famous paradox, i.e., in a universe so big and so old, why haven't we found any evidence of aliens? Well, according to the Great Filter hypothesis, it's because all life in the universe has at least one thing in common. During the course of our evolutionary development, we're all faced with a practically insurmountable obstacle that keeps us from interstellar travel. A great filter, if you will, that prevents 99.99999 onwards % of all species anywhere in the universe from making the journey to the stars. That would explain why we've never been visited by aliens. But the question now becomes, well, what could this Great Filter be? More optimistic proponents of this concept suggest that the Great Filter is already behind us. They say Earthlings passed it billions of years ago when prokaryotes, the first living organisms, evolved into more complex eukaryotes, or perhaps even earlier than this at the moment of abiogenesis, the first spark of life as it spontaneously evolved from non-life. After all, evolutionary biologists haven't found abiogenesis to be inevitable, even under ideal conditions. In fact, evidence suggests Earth existed for hundreds of millions of years before abiogenesis occurred as an incredibly unlikely fluke from the random interaction of molecules. So maybe that was the Great Filter. If so, the odds of there being other technologically advanced civilizations, or indeed any life whatsoever, spacefaring or not, in the observable universe are slim to say the least, and that would probably mean we're alone. Alternatively, the Great Filter, or another Great Filter, still lies ahead of us and must therefore be some sort of apocalyptic event. Only the total annihilation of all life on Earth would see to it that none of our planet's species ever migrated into space. And of course, humanity looks set to do just that, whether by nuclear war, environmental disaster, or high-energy particle collisions gone wrong, perhaps. Number 4. We're living in one matrix of many. We've probably all come across this one before, the theory that we're living in a simulation. Whether it's scary or not, well, that's up to you. For a long time, it's just been a philosophical thought experiment, a kind of unverifiable maybe. But what could make it scarier, for those who find it scary at all, is that scientists are looking for evidence of it. More specifically, they're looking for pixels. After all, if this is a simulation run by aliens or machines, or some kind of video game played by kids in the 10,000 and 21st century, then it should be made of pixels, right? Very tiny pixels, of course, and more than anyone could count, but pixels nonetheless. Well, it turns out the universe does appear to be quantized into fundamental units of matter, i.e. not continuous as previously supposed. To find pixels, though, we have to look beyond even the smallest particles, the quarks and the leptons, to the smallest measurement possible, the Planck length, or 1.6 times 10 to the power of 35 meters. To put this scale into perspective, you could fit more Planck lengths along the diameter of a grain of sand than you could fit grains of sand along the diameter of the observable universe. Yet despite these tiny, almost dimensionless dimensions, these pixels might give only a low-res representation of reality. Much like the resolution difference between our own reality and the video games we play within it, this simulated reality could just be a blurry hologram, a universe composed of three-dimensional pixels, each projected by their corresponding two-dimensional bit of information, an untold number of which plaster the outer surface of our sphere. Since the pixels inside would be bigger than those on the surface, any universe simulated in this way would be a relatively poor rendering of reality. If the universe is indeed a simulation or a video game, then it raises some interesting and rather frightening questions. But what may be even more frightening is the prospect that we're not in a simulation. This ties in with the Great Filter Hypothesis, because given the current rate of advancement of technology, getting from Pong to immersive VR in 4 decades, for example, it seems inevitable that we'll simulate the universe one day, even if it takes 1 million years. And it seems equally inevitable that simulations of the universe will become as ubiquitous as computer games are today. It's likely that many billions of people will be able to run these simulations from their living rooms eventually, and that's not even counting the simulations run by extraterrestrials or artificial intelligence. And what about simulations within simulations? Potentially, or inevitably, there may be trillions of simulated realities and just one true reality. Needless to say, our chances of living in that one real reality are many trillion to one. But if we're not living in a simulation right now, then it does suggest that humanity doesn't live long enough to create one, however much that sounds like a paradox. And, well, that would likely mean we're headed for an apocalypse pretty soon. Number 3. Nanobots will eat our planet. Alongside AI, VR, space travel, life extension, blockchain, and so on, nanotechnology is among the pillars of our tech-centric future. According to nanotech engineer K. Eric Drexler, it could usher in a new age of radical abundance. That's the title of his book on this subject, by the way. In this new age, tiny robots, 1/500th the diameter of a single strand of hair, combine molecules to create products on demand, much like a Star Trek replicator. This would revolutionize civilization. For one thing, it would eliminate wars over resources. Whatever we need, we'd just get nanobots to manufacture it. And since these products could be made to our exact specifications, they might even be superior to those that occur naturally. We'll probably see nanotech in medicine as well, including nanoscale functional particles that target cancer cells. In fact, the applications are endless, because what nanotechnology essentially represents is atomically precise controls over the very structure of matter. So, well, what could go wrong? Well, self-replicating autonomous nanobots could overrun our natural environment, including us, converting Earth's biomass into more and more nanobots until they shroud and then devour the entire planet in an ever-expanding swarm of grey goo. That sounds pretty bad. Nanotechnologist Robert Freitas refers to this hypothetical scenario as global ecophagy, essentially the eating of our home. And this is something that might happen pretty rapidly, even possibly within days, and we'd have very little chance of stopping it, unless, of course, we could create another swarm of nanobots to protect us. Number 2. Vacuum decay will delete the universe. There are competing theories for how the universe will end. Some think it'll be a big rip or a big crunch, while others say that heat death is inevitable. But each of these scenarios is billions of years away at least. Indeed, heat death won't happen for another Google years, and if you want to know how many zeros that is, well, here it is. Vacuum decay, on the other hand, could happen while you're watching this video. Everything in the universe, including the universe itself, tends towards equilibrium, towards the lowest energy or most stable state. It's easy to picture this if you imagine a large flat rock lying on the ground. The rock is in the most stable state. There's nowhere for it to fall, it simply won't budge. The rock is how we like to think of the universe. But now imagine there's another smaller rock on top of it. It's still pretty stable, but it's not in its most stable state. Something could knock it off. A hurricane with sufficient force, for example, could take it from this metastable state to one of decay, wherein potential energy is expended via tumbling to the ground. So what if our universe isn't the rock on the bottom, but rather the rock on top? What if our universe is metastable too? It's possible that one of the fundamental quantum fields, the Higgs field, may be an exception to this universal principle of stability, containing potential energy that it simply cannot expend. This is known as a false vacuum, which by its nature would be perilously unstable. Over time, it may actually absorb energy from particles in low energy states, effectively deleting them from existence. Vacuum decay may be visualized as a true vacuum, a bubble expanding at the speed of light and eradicating the universe as it goes, or converting it to a solid sphere of hydrogen. It would erase reality and its laws, including time and everything else, just as though it never existed, which it wouldn't have. And this could actually be happening right now. In fact, there could be multiple true vacuums expanding from different points all across the universe. They might just be so far away that even at the speed of light, they'll take billions of years to reach us. Or maybe their expansion is outrun by the expansion of the universe itself, in which case they're never going to reach us. It is, however, conceivable that particle accelerators like the LHC might destabilize things here on Earth, creating a true vacuum bubble that annihilates us in an instant. At present, the energy released in these experiments is dwarfed by the most energetic processes in the universe, so they're not considered a threat to the Higgs field. But it might be only a few generations before that all changes. And ironically, one of the reasons for building bigger and more powerful particle accelerators in the first place is to answer the very question of false vacuums. Number 1. The technological singularity will end us all. In case you haven't been paying attention, we've now got cool things like robots that can do backflips and AI that can deceive us. They can even predict our future with startling accuracy simply by reading the news. And, all of this stuff is pretty old hat. The development of artificial general intelligence, or AGI, that is, AI equal to human intelligence, is fraught with existential concerns. Often it's those who actually work or invest in the field who fear its culmination the most. Elon Musk, for example, publicly worries about summoning the demon or creating an immortal dictator from which we can never escape. Even Alan Turing back in 1951 said that AI will someday outstrip our feeble powers and take control. His colleague Irving Good agreed, suggesting the first ultra-intelligent machine would also be the end of invention, since AI would take things from there. The thing about AI and technology in general is that advances are exponential. Hence, in 2001, Ray Kurzweil quite reasonably predicted that in the 21st century alone we'll not see 100, but rather 20,000 years of progress. When non-biological intelligence, trillions of times better than our own, becomes the predominant type on the planet, we might even see a century's worth of progress manifesting in an hour or less. The technological singularity is a theoretical point at which advances happen so rapidly as to seem practically instantaneous to an unaugmented human intelligence. Just as the singularity within a black hole is a rupture in the fabric of space-time, says Kurzweil, the technological singularity will constitute a rupture in the fabric of human history. And he believes that this might actually happen by 2045. This, of course, is a rather optimistic scenario. It's a world in which AI doesn't wipe us all out, but it rather merges with us or assimilates into the human race. Others in tech are similarly hopeful, even if they do have vested interests. They foresee a world of infallible healthcare, automated workplaces, universal basic income, and AI-led solutions to climate change. But things, they could go differently. The runaway technological progress will be impossible for us to predict, let alone control. AI-assisted governments, they could outgrow and liquidate humanity. Even if they do remain loyal, there's the threat of misaligned goals. An AI built to make us happy, for example, but not sufficiently imbued with human empathy, might simply hijack our brains with orgasm-inducing electrodes. Whatever happens, one thing is clear. The technological singularity is coming, as if nothing else in this video happens first. So I really hope you found this video interesting. If you did, please do give us a thumbs up below. Also, please do check out our fantastic sponsor, the Great Courses Plus. That helps support this show. It's also fantastic, so click below to check that out. And as always, thank you for watching.